Good morning. Welcome to another edition of Chemistry on the Fly with Mr. F. Today we're going to be talking about metallic bonds, and that's going to be 4.30. Now, we know the chemical bonds, and that's all the bonds that we've talked about. They hold elements together to make molecules or compounds, and we know that there are three types. There's covalent bonds, ionic bonds, and metallic bonds. Now, metallic bonds are a little bit of a combination of all of those. So, first of all, metallic bonds share valence electrons, much like our covalent bonds. Okay, they occur between metals, which obviously is a little different than we've seen in the past. And then the other part, this is a little weird because they form ions when they get together, which is more like an ionic compound or ionic bonds. So, one of the weird things also about metals is that the rule of 8 doesn't apply. Okay, we know covalent bonds between two atoms, they share their electrons with each other. Okay, ionic bonds don't share electrons. One steals the electron from the other, very much like this one did. And what we've got with metallic bonds is we're going to have a little bit of sharing and a little bit of ionic. So let's take a look at how this is going to work. We're going to start out with aluminum. Al is its symbol. And notice that we don't have Al5 or Al3 or any number of aluminum. When we talk about aluminum, it's just one atom of aluminum because it gets together with a whole bunch of other atoms. So here's our atom of aluminum. We have 13 protons in the nucleus. We have to have 13 electrons since it's neutral. And we have 2 on the first energy level. We have 8 on the second energy level, which gives us 10. And then we have 3 on the last energy level. So those last 3, we've added a name for those, and they're on the last energy level. We'll call those valence electrons. We've called those valence electrons. We already know what those are called. Now the other electrons, we haven't really given them a name yet. They're going to be called core electrons. And it turns out when we get into metallic bonds, the core electrons stay where they are, and the valence electrons are the ones that are going to be shared. So again, one of the things that we see is that metals, they really don't hang out by themselves. They hang out with a whole bunch of other metals. So we're just going to put a bunch of aluminums here, all in a row and stacked on top of each other. Okay, again, this would also mean that they're in 3-dimension as well. It would be really tough to draw that, but they would be going into the screen as well. But this is what we've got. Now, as I said, we have the atoms become ions. So how does that happen? Well, the electrons are given up on the outer shell, and then we have our core electrons are on the inner. So we're going to draw our picture as the 3 valence electrons just kind of out there, and the core electrons and the nucleus are in the smaller electron cloud. And we're just going to, now what really happens is that these atoms, I told you that they share, but they don't just share with one other aluminum atom. They end up sharing with a whole bunch of atoms, and we actually call this the sea of electrons. So they hang out with just one atom, they hang around with a bunch of them. So they're just flying around all at different places within this sea of electrons. Again, I'm just drawing there to show that what it looks like. Now, one of the things that the sea of electrons enables us to do is that it gives the metal some very, very different properties. Okay, so one of the properties is a good conductor of electricity. So here's a positive and our negative charges. So we put a little bit of a They call it a potential difference between them. And what ends up happening is that the positive charge starts to draw the negative ions, or not ions, the negative electrons. So all electricity is the flow of electrons. And you notice that I'm not taking all of them. And there's some that are coming from other electrons or other atoms. So it's just a continuous flow of electricity. Okay, another thing that they're good for, these are properties of metals, is that they're good conductors of heat. So as an object heats, a metal object heats, we'll see that due to the electrons enable us to move energy, the metal heats up very quickly. And we see this when we have pots and pans and other things that we need to heat with. We do use metal for those because they're good conductors of heat. Similarly, things like wood and plastic, they're actually insulators, and they don't allow electricity or heat to flow very well. So that's why their electrons are not free flowing. There's no sea of electrons in plastic or no sea of electrons in wood to allow the energy to be transferred within it. Okay, another good property of metal is that it's malleable. Now, what does malleable mean? Malleable means that it can be compressed. So if I get a hammer and I hit it, okay, you can see that my surface actually dinged in a little bit, so it's actually compressed a little bit. And that's what malleable means. It means that I can compress and make my elements or my atoms into sheets of whatever, whether it's aluminum foil in this case, so we just squish them down until they become really thin, and that would be aluminum foil. We could do the same thing with gold. That's called gold leaf. We do that with a bunch of other elements as well, metals as well. Okay, another property of metals is that they can be ductile. Now, ductile is kind of an interesting thing too. What that basically means is that we can take our aluminum and we can draw it into a wire. Now, this is a very weird example of it or an illustration of it, but we can see that we're taking a bigger and we squished it down into a smaller, basically pulling it through a die and making it into a wire shape. That's what ductile means. Okay, another good thing about metals is that they have high melting points and high boiling points. This is also due to the strong forces that hold the metals together. There's some forces that hold water together or liquids together that we'll talk about next week, but they're not nearly as strong as the ones that metal have, so that we do have higher melting points for our metals. Now, we do know there are some metals, actually mercury and gallium, are going to be liquids at low melting temperatures, but that's pretty rare. Okay, one last review is we have from our metallic bonds is that first they share their valence electrons, and they would do that by creating a sea of electrons, and we know that they occur between metals. And the last thing is that once they give up their electrons, they technically become their valence electrons, they technically become ions. Well, that's a quick review today. That's all we've got. And as usual, have a great day. This is Chemistry on the Fly with Mr. Aff. Electrons don't necessarily make that a smaller picture. So you can see right now that we have our 3 electrons out there from each of the atoms. We'll see why in a little bit.